Hi, Spring fans. Welcome to another installment of Spring Tips. People have been asking me a lot about this new Spring Modulith project. This project is designed to help better describe your architecture. When Spring Boot first came out in 2014, I spoke everywhere, far and wide, high and low, telling people about the amazing opportunity that Spring Boot represented. And I told people that Spring Boot was a way to pair program with the Spring team. That is to say, why write all that tedious integration code to make Spring Security and Spring Web and Spring Data and Spring Navigation, whatever, all these different modules play well together when you could benefit from the wisdom and the sagesse and the insight of the Spring team and let them do that configuration, because who better to do it after all, right? Than, for example, having Dr. Dave Sire write the code for Spring Batch, etc. So it just seemed very natural, and it's worked out quite well. But we didn't really have a hard and fast sort of wisdom or guidance on architecture. And, at the time, we also saw microservices. And so I think it's sort of natural to sort of let people figure it out for themselves there, right? We wanted to let them just focus on their business logic, and to the extent that architecture was implicated in that, they could do that as well, right? And I think that was, if you're truly building small microservices, then really you don't really have a lot of questions around how you structure your code in the context of a service. But increasingly we're seeing people sort of create more medium-sized services, and also I think no matter what happens, no matter how many services you've got, it's going to get to the point where you're going to want to have modularity in a smaller service. And so we have this amazing project called Spring Modulith, which gives you architectural guidance on how to structure your code within the context of a single code base, a single application or a service. And it's just a very interesting project, and it helps people sort of avoid, I think, cargo culting some really bad alternative approaches. My least favorite, of course, is the sort of Ruby on Rails, and to be fair, Spring Roo, which of course borrowed from Ruby on Rails, the approach of having a models, a services, a controllers package, right? If you've got like app.controllers and app.services and app.models, you're probably doing it wrong, right? Just ask yourself, what would happen if you got rid of the word public in all your types? Does everything break? Then you're probably doing it wrong. Remember that in Java, the word public is not default. You have to add that in. It's opt-in, not opt-out. So why do we have our code base structured in such a way that everything needs to be public for it to work? Otherwise, it all comes crumbling down. We're denying ourselves the very privacy controls that the language gives us. So today, we're going to see how Spring Modulith can get us on the right track and make it verifiable, support observability, and ease of composition and integration via messages, via events. So let's go to our second favorite place on the internet, start.spring.io, and take a look. We're going to create a new service here called Service. I'm going to add Spring Modulith. I'll add the Spring Postgres support. I'll add Spring Data JDBC. Now, mind you, Spring Modulith works particularly well with SQL. And so for the moment, if I were you, I'd be using JPA or JDBC. And since I don't like using JPA almost ever, I'm going to use Spring Data JDBC. But you can do you, okay? It's fine, right? So there's that. We're going to add the Spring Modulith project as well. We've got that already. We're going to add the AMQP RabbitMQ support. We're going to add the web support. We're going to add the actuator support. We're going to add, what else do we need? Oh, we want Docker Compose to create the Docker file for us for both Postgres and for RabbitMQ. And I think I'm happy with those selections. Modulith, Postgres, JDBC, RabbitMQ, Web, Actuator, Docker Compose. Surely that's enough. Let's go ahead and hit enter and open this up in our IDE. So here we go. Okay, here's our brand new application, public static void main. Remember, this is a data-driven application, so we're using Spring Data JDBC, which implies some SQL, and it implies a domain. So let's talk about that. First of all, I think we're going to have a SQL database because we have this Docker Compose file and this RabbitMQ support. I want to actually use a different Docker Compose definition for RabbitMQ. So let me swap that out. Okay, so it's basically the same as before. I've exported the ports and I've swapped RabbitMQ to the management version, which gives me all of RabbitMQ plus a management console that I can log into to introspect the state of the broker. And I also want Spring Boot to start up the Docker Compose file when the application starts, but I don't want it to restart it each time. So I'll say Docker Compose start only. That way it won't start it and then stop it and then start it and then stop it, right? After all, your SQL database and your broker are usually durable, ongoing services, right? Okay. We also want to initialize the database, so we'll say initialize it if there's a SQL, schema.sql file here. I'll create a file here called schema.sql, and I'm going to describe two tables. So create table, if none exists, orders. It's going to have an ID, serial, primary key, not null, and orders line items. Okay, and let's see here. We've got this. It's going to have an int product, not null, quantity, not null, and of course a reference to orders, ID, like that. Okay, so we've got now our two different tables, one with a foreign key pointing to the other. Okay, so here's that. Here's our application. Now we go to public static void main service, and we're going to create a new module here called orders, and this is going to manage, yes, you guessed it, orders. Okay, so we'll create a new class here, and I never know what to name this class. Maybe we'll just name it after the visible, albeit not public thing called the orders controller. So at controller, at response body. And in this domain, in this module that we're creating, we're going to manage data of type order, integer ID, okay? And we're going to have a set of line items, okay? Line item, integer ID, int product, int quantity, okay? And let's see, this is a set, and this is a at ID. All right, there's that. We want to make this a table, orders, line items. Put that down there, and we want this to be just orders. And this goes here. Okay, very good. So we have two records, two different pieces of data. One, an order is the bounded context. It manages the order data associated with, all the data associated with the order, including the line items. And so we say that this is the aggregate. This whole thing is a bounded context. This is the aggregate that manages the life cycle of the line items. Okay, so that is where we shall define our repository. Extends list CRUD repository of order managing primary key of type integer. And maybe I want to have an order service. So actually, you know what? Just call it orders. Why not? And this can be a service. It'll be at transactional. And you don't have to do this, by the way. There's no reason you couldn't just put a lot of this business logic in the controller directly. But, I think people are accustomed to this sort of layering, and that's fine. But notice I'm keeping everything in the same code page. There's no reason you couldn't do that. The only limitation in Java is that if the type is public, there can only be one per code page. But again, most of my code, most of the time, I just have multiple types in the same code page. I have very large programs with maybe 20 source files, right? With 100 classes. It's not uncommon. And indeed, you can also nest things for a reason. The language gives you lots of ways to hide types, to hide data, to hide your implementation details, to not make them public. You want to be very explicit about the things that you add the word public to. So the order service will handle the work of placing an order. So here's an order. Okay, it throws an exception, I guess. Actually, we don't even need that. We'll do that. And what does that look like? Well, we're going to inject the repository. So there is that. Good. And we'll say this .repository.save order. And we're going to just assign that to a result, and we'll log it out. Okay. Var saved, system out, saved. Very good. Okay. So there's our very simple service as such. And we're going to create an endpoint here to sort of expose that functionality. Let's just request mapping orders void place request body order. Okay. Post mapping and response body. We want request body. Okay. Very, very good. And we'll inject this private file orders. Good. And this dot orders dot place order. Saved. Oh, whatever. There's the actual call to the order service. There's our basic arrangement, right? I think we've all written code like this. It's easy, right? This is a natural sort of a grouping of functionality. It's dealing with orders, and you can kind of understand that by looking at the package and the code. You notice that we're using these stereotype annotations. These are UML stereotypes. That is to say, they are documentational as well as functional. They tell us that this is logically a controller. We have it in the name as well, but that's mostly to appease the Java gods, right? We're telling Java, hey, I know I've got a type called orders already, so I can't have another type called orders, and that is disambiguated just by the annotation. Shame though it is. I wish I could. I wish Java would let me just call this orders and then not consider it the same thing as this just because the annotations are different, right? but it doesn't let me do that. So I'm doing that just for consistency. But basically, the important thing, the thing that tells me what role this thing serves in my architecture is the UML stereotypical annotation. And remember, in Spring, everything that is annotated with a component, even if it's another annotation, is transitively also a component, right? So this is actually just another Spring Bean. It's a regular Spring Bean, but semantically, we also know that it is a HTTP endpoint. You don't need a package to tell you that, right? Okay, so let's try this out. I think we've got something. We've got our schema, right? We've told it to initialize it. We've got our basic module definition here, right? We've got some code dealing with orders in the root of the code base. I think that should be it. Let's go ahead and try it out, huh? Okay, that first time it started up, it had to start up all the infrastructure in Docker, so it took a bit longer. That's okay. We're up and running. Good stuff. Let's try this out. So curl d -x post -h content type application JSON HTTP localhost 8080 / and then we want to publish this to orders, right? And what data are we sending? We're sending some JSON data like so. Line items, okay, and then we'll have some data in the line items array, quantity to product 1, okay. Hit post, and you can see that it saved the data, and we want to see this in the database, I guess, so we could create a new console here. So pg password equals secret psql u my user h localhost my database. Does that work? Yeah, that works. Good. So there's the table. Select all from orders. Good. Select all from orders line items. There we go, right? So it's successfully written data to the database. Great. So we have one module. Now, this module is concerned with the actual placement of orders from the user, right? But presumably they're working with an inventory of product. You can see that reflected here, the product ID. Well, who or what is managing the catalog of products, right? Well, that's it seems to me logically another service. So let's go another module, in fact. So let's create another module here called products. And I want this products package module to deal with the life cycle of products. Okay. Now I might have a method here that I can use to sort of update the inventory or decrement the quantity or whatever. And I could probably inject that here in the order service, right? I could inject product into the order service. But first of all, now I've got one package, one module with a dependency on another. This is not necessarily a problem, but do we need it? Do we need that dependency here? And what happens if one day the products package has something that it needs from the orders package, right? You want to avoid that dependency whenever possible, right? You want to avoid tying things in a bidirectional way, right? You want there to be a graph, a directed graph of dependencies. So if I make the decision to inject the products service into the orders service and then have some logic here to products dot decrement or update inventory or some, I don't know, whatever, right? If I decide to do this someday, that's okay. Again, it's not a big deal. But what if I also have another service for fulfillment? Okay, fulfillment, send fulfillment, right? Now I'm adding this logic. And what if I also want to do something else, right? You get the idea. I have a lot of collaborating sort of things that need to be aware of what's just happened. And I need to now pull into this. And this order service ends up being a funnel through which all logic ends up sort of sitting and routing. I don't want that, right? It creates an undue burden on my orders module. And especially since these other things, again, if they're so key to this functionality, then arguably they should be part of this module, right? I tend to think if you've got so many dependencies on other things and those things can't be useful outside of this particular transaction, then maybe they're not useful, right? But in this case, they can be, and they are. They don't need to be part of this transaction, or rather, they don't need to be injected into this code, even if they want, for example, to be part of the transaction. So how can we do that? Well, we can use a little bit of, the ancients are stealing our technologies. We'll just use messaging. We'll use events. And this gets us to a very good question, which is, what do I mean by event driven? And this is well analyzed and answered by the good, the great, the amazing Martin Fowler in this blog from 7 February 2017. And he describes 4 different types of event driven styles. Event notification is using a message or an event to notify another system of the fact of some event, right? So it's it's a mouse click event that doesn't tell you where on the screen the click happened. Or it's an event saying, hey, the product's catalog has been updated. It's up to the listening to the notified party, to the notified system, to take the event and then do whatever it needs to query the source system for the details, right? So for example, imagine that example I just gave you. Imagine somebody's added a new description to a product in the catalog, okay? Well, if I'm the search engine service, if I'm the search index service sitting over here based on Elasticsearch, well, I'm not gonna, I don't really care which product was updated. I can just delete everything and re-index the entire product catalog. I might need to do that anyway, right? And in this case, it's very simple. I get a notification that something has changed. Fine, I just re-index everything. And then I do that no matter what, right? So maybe that's a little inefficient, but you get the idea. It's very simple, at least. If there's no need for me to know the details, then I don't send the details. It also means I'm not conducting data from one component to another. And, in the case of distributed systems, I'm not sending data over the wire unnecessarily. Sometimes just knowing something has happened is enough to know what has happened. Sometimes, however, it's not. Sometimes you need the details. Sometimes it's too painful to send information to the source system, to the notifying party, right? Sometimes it's too painful to query the source system for the details of what has changed for every single change. So instead, you send the data in the message itself. Now you're offloading the work of distributing that data not to the source system, which might get overwhelmed if every other if every other component in the system started deluging it with requests, but you're offloading that now to the broker or the thing that's conducting these events. And so event carried state transfer is that pattern, and it's very useful if you have a lot of data and you'd rather just send the data in the message body itself, or if it's a small amount of data and you don't really worry about sending the data in the message body itself. Here, the details of the change, not just the fact of the change, are communicated in the event. This is very good because now I, as the notified party, don't need to query the source party, the source component, for the details. And eventually, if you start doing this correctly, your whole system becomes a series of events. And you start to realize, oh, okay, well, if I send an event with some details about what has changed, and the Elasticsearch index gets rebuilt, and I send details and I update the Postgres database and I update the whatever. I update all these different things. I add new images to the CDN for the new photos for the product, whatever. All these things happen in response to messages. Well, then it becomes kind of obvious, which is something becomes kind of obvious, which is my system is the sum of all the events, all the messages it has received. Put another way, if I deleted the CDN and I deleted the Elasticsearch index and I deleted everything except for the events that were sent via Kafka or some event store, well, if I then take all those events in the order that they were originally received and replay them, starting from the very beginning, publishing that message, and then replaying every message after that in the same order as they were originally replayed, I will arrive at the same system, right? The same images will be in the CDN, the same Elasticsearch index will exist, the same transaction data will exist in some sort of warehouse, whatever. This is a very, very powerful concept. It means that the system itself, the system state, is a reflection of all the events that the system has had, right? Very, very interesting. And in that arrangement, you start to realize, okay, well, I'm using an event to publish the fact of a change to other things in the system. Those other things in the system have got their own view of the world. And so there's no single place in the system I can write to then update the state. I'm going to read from lots of different places, right? I'm going to read from Elasticsearch for doing searches. I'm going to read from Postgres for the transactional online data. I'm going to, whatever. I'm going to read from the CDN for the pictures associated with the product, etc. And in that case, the insight is pretty simple as well, which is your system is made of different things for reads than it is for writes. And that gets you to CQRS, Command Query Responsibility Segregation. And it's the notion that you have separate data structures for reading and for writing information, not just because separate data structures are sometimes more functional, but also because it's more efficient sometimes. I mean, Redis is not I wouldn't, I don't think a lot of us would use that as the main data store, although you certainly could. It has the technical capabilities, but if you're using it as a cache or something like that, then it's going to be a optimized read data structure, right? I put data in there so that I can read things very quickly, even if I'm writing to Postgres, for example. So these patterns, I think one flows naturally from the other. And in our case, I want to take advantage of, I don't know, maybe it's the first one, maybe it's a little bit of the second one, but I want to do this in our modular code base. So let's now we've got our products service here, and we want this to be at transactional. Okay, and we're going to listen for an event. Did you know that Spring has had an event bus since basically 1.0? Well, it's here, and it's called the application event publisher. Okay, inject that, voila. Okay, and I'm going to go here and I'll say this.publisher.publish, and I'm going to publish an event. And this event is the first thing I'm going to create that's public. So order placed event, okay, public record. And I don't know what I'm going to send. Maybe I'll just send the order number, okay? So order placed event, new order placed event, saved.id, okay? So I'm going to publish that event, and I'm going to let other things in the system that are aware of it or that want to know about it listen for the event. So I'll say void on order placed event. Here we go. And I'm going to print out, okay, starting, right, thread.sleep 5,000 seconds or 5,000 milliseconds, okay? And we'll then stop, right? So we're done processing here, but we slept 5 seconds before we finished the transaction, whatever. So logically, this is some sort of logical transaction. Let's just imagine it is, okay? So I'm going to go ahead and now restart the application and go to the command line here. I'm going to send the same post, but notice that it's not returning. I've got my hands here. I hit enter, but it's not returning just yet. There it is. About 5 seconds later, it returned, and we got our write. Okay, so go back to the console, and you can see it started, and then 5 seconds later, we got the stop. Okay, what this means is that I wrote to my orders module. I did some work in the orders module, and then I published a message so that I can be decomposed. I want to be decomposed from other things in the system. But somehow I got the worst of all worlds here. I'm using event-driven messaging, but I'm still synchronously bound to other things in the application context. And so there are things I could do to get around that. One thing I might do is make this async, right? But of course, I still want this to be a transaction, so I would add transactional, and it gets pretty tedious. So if I did async, this would spin up and it would run in its own transaction on a separate thread. That could be enough, right? But first of all, can I make this less verbose? Well, certainly I can use application module listener, and this in turn is at transactional listener, so it's an event listener, and it's transactional, and it's async, right? So in theory, if I go back here, then in theory, I don't really need that anymore, right? So this gives me 3 annotations for the cost of 1. But the second problem is, what if the power gets killed before we finish the transaction, right? What if I pull the plug on the machine before this finishes? Well, that's a big problem, right? And so Spring Modulith has a very nice way to handle this, which is it can republish outstanding events when the application restarts. And we can enable that here. We can say Modulith JDBC outstanding events republish on restart. Yes. So Spring Modulith republish outstanding events on restart equals true. And then finally, Spring Modulith, we want to enable the schema there. And so now let's restart that. Okay. And if you go to our SQL database, so we've got republish Spring Modulith republish outstanding events on restart equals true, and then we want the Modulith schema as well. So schema initialization is equal to true. Let's go ahead and restart that. Okay, good. So now if we go to our SQL database here, you can see we've got this table called event publication. So D event publication. It has the listener ID, the event type, the serialized event, the publication date, and the completion date. So select all from event publication. There's nothing in it at the moment. Now let's try our write one more time. So go back here, repost. It returned immediately. You can see it's got a record in there, but and it finished, right? So we got that there. Let's make this write a little bit longer so we have enough time to intervene. So I'll restart that. Okay, delete from event publication. Voila. And select all from event publication. Good. Now we repost this, and we say ID completion date. Okay, so the completion date is null, right? Waiting 10 seconds, and now the completion date is not null for the last 3 here. So it's published the message, it eventually got processed, and the completion date was set to null, to non-null. Okay, great. So let's try this again. This time we're gonna stop it, right? So here it is. there's one with a null thing, Control C. Okay, the process has been terminated. Select that, and we still see the completion date is null. Okay, now let's restart the process. Okay, we're waiting for it to give us the confirmatory stopping in about 5 seconds. There we go. So it's actually replayed the event and marked it as completed. So even though we lost the message, we didn't get to finish the message, it got a chance to run on restart. So this is great because I can use the Spring Event Bus, but not pay the cost of waiting synchronously for all the other components in the application context to finish. This is also great because it gives me a chance to make sure my system is always in a valid state. That said, it's possible that event handler might get run multiple times. And so it's very important that you design your system to be idempotent, right? You don't want to have undue observable side effects just by running the same event handler more than once. Okay, good. So we've got a pretty good integration here. We're using events to decompose our modules. I like this a lot. It's very clean, very elegant, very simple, very easy to understand, and it just requires the stuff we already have, which is a SQL database and Spring. Okay, but what if I have another system that's not in the same modulith, right? It's not in the same modular monolithic code base, and I want that thing to be able to listen for events as well. Well, Spring Modulith has you covered here as well. We're going to use RabbitMQ to integrate other systems. So we need to add one module here, Spring Modulith Events AMQP, Command-Shift-I to import that. And then we need to set up some configuration for our AMQP integration, right? So AMQP integration configuration, when basically we need to configure the broker machinery for sending and consuming messages in RabbitMQ, which I've got running on my local machine thanks to that Docker Compose file. And remember, in RabbitMQ, you have an exchange. This is the door into the broker that clients sending messages address their messages to. It gets to the exchange, which then use some sort of routing algorithm, usually point to point or pub sub or whatever, and it routes it to a queue, right? And then that queue is where consumers listen to. So producers produce to the exchange, consumers consume from the queue. They're not the same, right? They don't share the same location. This indirection is very convenient because it means that I can reroute them. I can add hops in between without either side being any the wiser. So we need to make explicit this arrangement to link the queue and the exchange with a binding, which we'll do here. And also, one of the nice things about AMQP is that it's just a network protocol, and it supports creating machine, infrastructure like the queues and the exchanges and the destinations and all that stuff. It lets you create that in code via the network protocol. So we'll say static final string orders queue equals orders. Okay, and I'll say queue builder dot durable dot build. Very good. And we'll pass in orders queue, and we need the exchange as well. So exchange builder dot direct exchange orders queue dot build. Okay, and we'll inject that here. We'll say return exchange binding builder dot bind queue exchange. Okay, queue dot to exchange dot with, and we need to provide a routing key. This is to say, based on the message that comes into the exchange, if it has a header, a key value in the message envelope, if it has a header of a particular value, route it to this particular queue. So we're saying if the special key, the special header called the routing key is equal to orders, then send it to this queue from this exchange. Okay, so that's what this binding is making explicit here. We're linking these two things together. Let's put this up there. Very good. Okay, so now we're going to, how do I tell Spring Modulith to send this message that we've just published to RabbitMQ or to Kafka if I had used that? Simple. Just annotate the event, right? Externalized. Voila. Okay, and the target will be orders integration. What do we call that type? That type is called AMQP integration configuration dot orders queue. Okay, that's it. Oh, this shouldn't be called orders, should be called queue. Sure. And you should really be better at naming this than I am, but whatever. Let's just go ahead and go with that. All right, let's start this up and running. All right, so now we're going to go here, publish the message, and visit the RabbitMQ broker. And that running, like I said earlier, I used a RabbitMQ instance with a console that we can log into. So 127, and then it's my user secret. Okay, not now. All right, so you can see we've got a message. it sent a message to the broker just now, right? It's a brand new instance of RabbitMQ, but we got one message. Thankfully, we got the orders queue as well. You can see that right here. So good stuff, right? This is the nice thing about this is now any consumer, any microservice written in any language that supports the AMQP protocol can consume and work with events being published from this modular monolithic code base. So we've got modules and they're in good order, and we've assured that there's no direct connection between one and the other side, right? But there could be. Remember, I'm using events to decompose these things so that they're not connected to each other. But there's no rule against that. It's just that you got to like minimize it wherever possible. So I could actually have another class here and then I can inject that into this, and that's fine. But how do I know it's fine? I guess is the real question. What can Spring Modulith do for me to help me understand whether my code is in working order? So let's go to our test here and see. So there's actually this nice thing in Spring Modulith called the application modules. And I can get the service application.class. There's that. Modules dot verify. So I'm going to verify now the arrangement of my modules. Let's go ahead and run this code. Run this code. Oh, it's saying it doesn't know about our SQL database. That's fair. So, because remember, we're not using test containers here. We're using Docker Compose. I guess the easiest way to get around this is just to do this. It's just secret, and the URL username is my user. URL is jdbc:/postgresql localhost my database. Ditto for AMQP, RabbitMQ, password is secret, username is my user, and restart that test. Okay, so you run the test, and it looks like everything's fine, right? It's not complaining anyway. So there we go. So what does it know that we don't know? Well, let's ask. We can actually look at this code here and print out information related to each module. So for var m modules, system.getName, m.get base package, right? So I'm going to call this module like so, and then just rerun it. Here we go. Okay. So look at that. It's actually given us, and it knows about how our modules are in module, order, base package, etc. And it knows the types in that module, and it knows the dependencies. So it knows there's no issues. What are the issues that it would discover though? Well, first of all, it doesn't want tangles. It doesn't want one package consuming one thing from the other from another package, and then that package consuming something else from the first one, right? They shouldn't be bidirectional. We want a directed graph of dependencies. So one should inject in one direction, right? You don't want to have bidirectional injection across packages, across API packages. Another thing that you don't want to do is to consume things that are in implementation packages. So let's say I go here and I say impl, which is, please don't, but you might have something like, imagine you have validation logic or something that's internal to your implementation of the orders module, but that nonetheless deserves its own package. Maybe it's because it's of a particular niche or ilk or whatever. So let's say I have I don't know, whatever, just a bean, okay? It's just a bean and it's public for some reason, and I'm going to inject that here. So private final validation. Okay, I'm just injecting it. That's all I've done. So let's rerun this test, and it's broken the test. See, it's actually saying, hey, look, you violated the visibility, right? Module products depends on non-exposed type validation within module orders. Now, of course, if I move this to the top level like this, so it's not like an implementation package, things get better. Let's rerun that again. Green, right? So it assumes that the top level types are going to be the ones that are public. That's the API for the module. But everything internal to that should be hidden, and so you shouldn't be able to inject those things. So even if you do use the public keyword because you have internal implementation packages, as long as you're only using it within the module, the test will be green. See how nice that is? So obviously, let me get rid of that. I don't want that. So this enumeration, this ability to understand the arrangement of our components in the system and to sort of validate them is really, really powerful, because it means that we have an extra thing watching out for us. It's no longer just the compiler and the keyword public or package private or whatever. And you can actually use that to your advantage. You can actually get it to create documentation for you. So if I pass in modules and I say with write individual modules as plant UML, write modules as plant UML, etc. And then I rerun this. Okay, let it run. And now I go to my target directory. You can see it's got a generated Spring Modulith docs folder. And if I look at this, how cool is that? I've got a plant UML plugin on my IntelliJ here, but it actually gives me architecture diagrams, right? It knows the arrangement of my modules within this service called the service application, the container. It says products listens to events from orders, right? So it's showing me the component and the container boundary. Oh, that is so cool. And I can now include these diagrams in my documentation. I can give them to architects. I can do whatever I like to kind of understand the arrangement, the system, the architecture of my code base. Okay. All right. So we've got externalized messages. We've got message decomposition. We've got, good tests that help validate the arrangement, the structure of our code and the modularity of the code. We've got, we're using packages finally correctly in the Java language. We're using the public keyword correctly, which is to say sparingly correctly. So I think we're doing pretty good. I think it's, at this point, you'd probably want to worry about production. Obviously, in a production environment, you want observability. And we just saw that Spring Modulith has an idea of the arrangement of your system. So let's expose that to an actuator endpoint as well. So show details always. And there is a modular endpoint that you can enable here. Management endpoint modulith enabled equals true. It's enabled by default, but just keep that in mind. You might want to disable it as well, conversely. So web exposure, show details, fine, restart. Oops, not that one, this one. Okay. Localhost 8080/actuator. There's our actuator endpoint. Go to modulith, and there's the same kind of information that we saw reflected in the plant UML diagrams and in enumerating the modules there in the test. You can see all that reflected here as well. It knows about the modules, their name, the package, the dependencies, the type of dependency, etc. Very, very, very cool. So hopefully, my friends, you've got a sense of what you can do with Spring Modulith, why it's so darn useful, and why, frankly, I think you should start all projects with Spring Modulith. It's sort of the architectural wisdom. It's like pair programming with the Spring team for architecture, not just for configuration. Obviously, we've only begun to scratch the surface here. There's a lot more to the amazing Spring Modulith project, and more all the time. And I've shown you a clean room greenfield sort of approach to using Spring Modulith, but obviously a lot of people are going to take this technology and they're going to try and modularize existing code bases. And so there's a whole lot in the Spring Modulith project that's been added to sort of pragmatically make it easy to incrementally add this to your project, right? Including the ability to provide exceptions for what packages should be visible or not, including different kinds of integrations. I mean, just a lot of really, really well thought out, nicely done stuff. So I hope you'll take a look at it. As always, start.spring.io. Thank you so much for watching, and as always, we'll see you next time.